Hello, thank you for watching. This is topic 1, interval estimation hypothesis testing. It is usually the case that we are trying to estimate something of interest. Maybe it's the parameter of a population, which we would denote as theta. However, trying to find an exact value of the data can be a bit difficult. So interval estimates are useful because they produce a range of values which may contain the parameter of interest. Let's visualize this with Cupid's job of matching men and women. Suppose the criteria that Cupid uses to match men and women is based on IQ scores. Two people are a good fit if they have the same IQ score. We can assume that Cupid owns two large books. One is a list of males with their IQ scores, which is up to date, and the second is a list of females with their IQ scores from 2 years ago. First, Cupid strikes a man with an IQ of 100. Then he strikes a woman that also has an IQ of 100. Since the IQ scores for the women were taken 2 years ago, it's possible that they could have changed. And this interval represents the possible values that the IQs could have changed to. Ideally, we want a measure that works for any man that Cupid strikes first, and for a woman that Cupid strikes second. Therefore, these lower and upper bounds will determine Cupid's level of confidence in determining whether or not he made a good fit. Let's look at the particular case where Cupid found Homer. So Cupid found Homer. Now Cupid needs to go out and find a woman who also has an IQ of 60 as well. However, the IQ could have changed since the IQs were taken 2 years ago. Let's assume Cupid wants to be 95% confident that he has selected a woman whose IQ has not changed, which will be depicted by this area. What that means, so if Cupid is to be 95% confident that this woman and Homer are right for each other, then 1 minus 95%, or 5% significance level, is the probability that Cupid will reject these two, given that they both have the same IQ. This is the probability of a type 1 error, which we denote as alpha. Now let's assume that the woman's IQ did indeed drop, and it's much lower than what we constitute as being a good match. So Homer's IQ is 60. Let's pretend at a 5% significance level, any IQ between 55 and 65 for the woman would constitute nearly identical scores. Now it turns out that the woman's score is actually 50. Then the probability of accepting the woman, given she is not a good fit for Homer, is equal to beta, or it's the probability of making a type 2 error. However, if Cupid wants to decrease the probability of making this type of error, then he will also need to decrease his level of confidence. The power is like confidence, and that power is 1 minus beta, and it is the probability of accepting the man and woman as being a bad match given they are indeed not right for each other.